Now we'll take a look at how the Model Context Protocol or MCP actually works in practice. We'll do this by connecting multiple AI tools together, maybe like a weather service and a math engine, and let an AI agent use them in real time. So let's start our coding part. First of all, I've created a virtual environment in my project folder, and then I have created a requirements.txt file, and then I've added the following requirements here. Now what I'm going to do is I'm going to create a weather.py file, which will be one of our MCP server here. So weather.py, let me write down the code. So from MCP dot server dot FastMCP import FastMCP. Okay, FastMCP. Now we are going to initialize this MCP object using the FastMCP server, and then we'll name this weather. Now this will be just like a tool in our langchain or langgraph here. So we'll define async def get underscore weather. We'll provide a location, and then the location will be passed in string, and then we will return a string here for the weather update. So in docstring, what we'll write is get the weather location and provide the weather update. Okay, so this will be a doc string for this particular function or tool here. So now instead of going to some API, what I'm just going to do is I'm going to say it's raining heavily here. Okay, so this will be my weather get weather function, or my weather server defined in terms of MCP. Now what I need to do is I need to run this server. So if name underscore equals to, it has to be double equals to here, main, then we will run this as an API server, and then mcp.run. We always need to define a transport approach for this particular run here. So for this one, we are going to do streamable http. Okay, so this is the code for our weather MCP server. So what we have done is we've started by creating a small MCP server using FastMCP here. So you can think of this as a tiny web service that knows how to answer weather related questions. Here we've defined a tool called getWeather, which accepts a location as an input and returns a response here. And yeah, for now it is only hard coded here. Now the main thing you need to understand is this particular last line of code here. So what this last line of code does is it tells the MCP to run this as a streamable HTTP transport, which means the weather service will run as an HTTP API capable of streaming data, similar to how like OpenAI's response stream token by token. So what this does is this makes it easier for other AI system to connect to this particular like connect to this particular service over the web without needing for local access. Now what I'm going to do is I'm going to create another file called mathserver.py, and then create few of my mathematical functions in this particular mathserver.py file. So again, we start by importing FastMCP from mcp.server dot FastMCP import FastMCP. We will name this MCP server as maybe math, and then we'll do MCP tool, mcp.tool. So right, add function which takes in two parameter, integer a and integer b, and then it will also return an integer here. What this will do is add two numbers, and I'm going to do return a plus b here. Similarly, I'm going to add another MCP tool which will be for multiplication, which will again take in two integer number, and then it will return the product of them. So multiply two numbers and a into b. Now again, since I need to run this particular math server separately again, so I'll write the main code here to run this. So mcp dot run. So again, we need a transport, and transport is stdio. So here we have defined two tools, one for addition and as well as other for subtraction. And then down in the bottom here, we again see a transport stdio. So what this means is the math server will run using a standard input output as communication method instead of HTTP. So in other words, you can also say that math server will talk to other systems through the command line pipes, making it lightweight and fast for local operations. So the particular method is also good when you're running multiple AI tools on the same machine, since it avoids network overhead. Now we'll finally write our client part. Since we already have our two server path, now we'll write our client path. So now create a file called client.py, and here what we're going to do is we are going to import langchain underscore mcp underscore adapters dot client import multi server MCP client. Similarly, from langgraph.prebuild, will import create react agent. We'll also import our model from langchain underscore google underscore genai, and the model is chat google generative AI. And finally, we will load our credential here. So from dot env import load.env. Okay, for this part, what you need to do is you need to create a .env file here, .env file, and then inside this .env file, you need to define your Google API key in order to use that chat Google generative model here. So you can paste your key here and then basically run the code. So now we'll load our credential using load underscore .env here. Load.env. So we'll load our credential using load underscore .env function. We'll also import async IO here, and I'll tell you why we do this using asynchronous mode here. So first of all, we'll define async def function, async def main. Now what we need to do is since we are using multiple MCP servers, so we will initialize this multi-server MCP client object, and inside this we're going to define the two MCP servers that we have. So the first one is math server, and this math server is run by the command python, and then the argument is basically mathserver.py, and we also need to provide the transport that we have defined. So the transport is stdio. Okay, now similarly, we have another MCP server called weather. So for weather, since it will run as an API endpoint, so we need to provide our endpoint here. Once we run that particular server, how it is going to run is it is going to run on this particular URL here. So the URL is http colon double slash localhost, because I'm running everything on my own machine here, a local machine. So it will run on localhost 8000 slash MCP server. And then we have also defined our transport mode for that. So the transport mode is streamable HTTP mode, or streamable underscore HTTP mode. Okay, let me confirm this real quick in our weather part. So this should be streamable underscore HTTP mode here. Okay, now we already have two of our tools here, right? So now what we're going to do is we're going to do tools equals to await client dot get underscore tools. So this client is this particular object here where we have connected the multiple MCP servers in this model. Now we define our model. Model equals to chat Google generative AI, and the model name is Gemini 2.5 flash model. Now after this, what we need to do is we need to create our agent here. So agent will be created using create react agent, where we'll pass in our model as well as the tools that we have. Now for the math response, we'll do math response equals to await. We'll invoke our agent with a mathematical query. So agent dot invoke, the query should be in the form of messages. Then we need to provide a role here, and then inside this again we'll provide a role. The role is going to be a user, and then the content of this message is going to be, let's do what is 2 plus 2 into 5, or we'll keep one of the brackets here, 2 plus 2 into 5. Okay, so this is our query here. So now what I'm going to do is the response will basically be in math response. So I'm going to print this math response here. And then if I need to just print the content, then what I can do is I'm going to add 2 empty line spaces. Then I'm going to print math underscore response dot, or sorry, we need to print out the messages, and then we will go for -1 dot content, which means we're selecting the last message from math underscore run. Now what we're going to do is async io dot run here. Okay, so this is all for the code. So if we have to talk about this file again, we see that what we are trying to do here is we're trying to bring both of those MCP server that we have defined together using a client in this client.py file. So we use a multi-server MCP client to connect both the math as well as our weather server at once. So each server is actually registered with its own configuration here. The math server through stdio, and then the weather server through streamable HTTP. So after connecting, we call get tools, which fetches all the available functions from both of those MCP servers. So now our client knows that it can use tools like add, mul, and get weather without us hard coding them anywhere, just from the MCP server themselves. Then what we do is we create a LangGraph React agent and a Google Gemini model. So this agent can now reason through problem and automatically decide when to call our MCP tools. So, for example, when we say what is 2 plus 2 into 5, the agent will break that down, call the math server add tool first, and then the multiple server, and then the mul tool, and then finally now will return the result. Uh, Also, I told you that I would be talking about this async keyword here. So why are we using this async keyword and then basically calling this async io.run is because what we want to do is we want this to be programmed in asynchronous programming mode. So since our MCP server may take some time to respond, especially the HTTP server. So what Python does is it uses async IO to handle these calls concurrently. If I have to say it in simple terms, async IO allows multiple tasks like contacting both the math and weather server to happen at the same time without blocking each other. So it makes the entire process smooth, efficient, and ideal for real world AI system that uh, depend on multiple tools running in parallel. So now let's run these two servers and then see if what kind of result do we get for this particular client. So at first we're going to run weather.py, but here I've made a mistake. We need to keep the main with underscores here, and then streamable HTTP will be with a hyphen and not with an underscore. So if we run python weather.py, then you can see that that the weather.py server is being run here. Now we'll also run our math server here. So python mathserver.py. I think I made a mistake here too. So this should be with double underscores. Mathserver.py. And then here we should have a space here. So save this again, and then now we can also run our mathserver.py part here. So this is running. Now these two MCP servers are running quite well. Now we can also run our MCP client here. So for that, I've forgotten a comma here. So I'm adding this, and then I think I've made a mistake here. So this should be small l, and the same should be applied to this particular object installation here. So let me clear this, save this, and then run python client.py. So now as the query is being invoked, so there are MCP tools being called here. So not this one, but I think one of the tool is being called, and then we have an error. Let me check what's happening here. Okay, so async io.run will not only work, we also need to provide what do we want to run inside this. So let me clear this again, and then run python client.py. So yeah, you can see that something is running here with the math server. Is it math server or like is it with uh streamable HTTP? Anyway, if we look at our third terminal here, okay, so we do have some mistakes here. Let me check what the error is. Okay, so before we run this, make sure that you have your SDK key or like your API key, especially the Google API key in your .env file. Now what I'm going to do, I'm going to run python client.py. So this is going to handle all of our MCP clients. It will take in this particular query here, and then it will perform an asynchronous query to asynchronous invoke of this particular query with our agent, where our agent is connected with models and tools. And then you can see that we already have our answer here. So yeah, if you can focus on this, then you can see that we have a tool called add here, where we pass two parameter 2 and 2, And then we also have another tool called, let me check here where that is. So yeah, another tool called here is mul, where the arguments are 4 and 5. And then basically based on that, the model has generated our output that the answer is 20. Now if we want to ask something else here, let's say also tell me the weather of Kathmandu, then we'll see what our model uh, generates for the response. What it should do is it should give me this calculation, and then it should also call this weather tool, which we have here, and then from here it should generate a response. It's heavily raining in Kathmandu, because the weather always returns it's heavily raining here. So yeah, it this is how simple it is to create MCP servers, and then connect these MCP servers using our MCP client here. So I hope it runs on your end as well. If you have any problem, feel free to comment down below and I'll try to help you out. And I will see you in the next video again. Thank you.